Let's look just a little bit at teleconnections, the idea of teleconnections, which basically means impacts far away from where the action is happening. So we said El Nino is mostly about perturbing temperatures here and here, but depending on the season, so this is the northern hemisphere summer, which is our monsoon season, you can see that the Indian region tends to be warm and dry, well, drier than normal, and this whole region tends to be drier than normal as well. I'll show an image of dust storm from one of the cities in Australia, and you can see that the region here gets wetter because the convection has been shifted eastward, and this is in the summer, so El Nino peaks in the winter months. So obviously it is still evolving. As we said, El Nino takes 9 to 12 months to evolve, and there are some dry anomalies over here. So away from the action, because of the perturbation to the Walker cell and the Hadley cell, you begin to get some signals which you can barely see here. You begin to get some rain, or at least mountain orographic rain and so on. In the Boreal winter, northern hemisphere winter, the teleconnections go much further because now you are in the peak of El Nino with maximum warming in the east, maximum cooling in the west. Obviously not always, as I said. So you can see that the wet anomalies have extended all the way into southwestern, southeastern US, into Argentina over here, northeast Brazil region, of course the coastal oceans, southeast Africa, island nations over here, all the way into China and Japan, Alaska, northeastern US, and so on and so forth. So these are called teleconnections. If we look at the summary of the consequences, this is showing impacts on marine life, floods, coastal erosion, droughts, coral reef damage, bird life impacted, forest fires, tropical storms, and so on and so forth, right? So you create such a large change in distribution of warm water that obviously are going to affect things like cyclogenesis, or the formation of hurricanes and cyclones, which are called typhoons here, cyclones in the Indian Ocean, and hurricanes over here. Warm waters also affect corals. It's called coral bleaching. Basically, the symbiotic algae that give color to the white base of the coral polyp becomes discolored and becomes white, so it's called coral bleaching. And you get droughts, forest fires, some human action involved there, and upwelling is reduced over here, so you get reduced phytoplankton production. Fish that cannot run away can die. Birds that depend on them can die. Warm water spread all the way up and down the coast because of some waves that are involved that we haven't touched on in this book, in this course. So they bring along tropical fish all the way up into west coast of US, Oregon, and so on, sometimes when the El Nino is strong. Of course, you get heavy rains and floods, as we talked about, and you get droughts over India and parts of Africa as well. These are the consequences of El Nino, and damages during El Ninos can amount to several $1 billion. So the prediction business is important. Of course, predictions can be used to make money as well by betting on grain productions, fish productions, repairing roofs for the coming heavy rain season, and so on and so forth. So doesn't mean you have to stop producing forecasts, but it becomes social science at that point. Making accurate predictions is natural science, climate science, but how it is used is really social science. These are images of dust storms over Australia in Melbourne, I think, during strong El Niños. It gets very dry, rainfall disappears, and you get dust storms because Australia has a large part which is very dry and desert anyways. And there is some data that shows that beer consumption during El Nino goes up in Australia because it gets dry and hot. Do people really need an excuse to drink beer? No, but if it's dry and hot, you can expect that probably people tend to drink more beer. So those are some of the teleconnections of El Nino. There are many more which we won't go into, but I'll come back to this a little bit when we talk about the monsoon in the coming podcast. So you can see each topic is a short introduction, but you can read up more, considering this is focused on ocean atmosphere dynamics, and we are just kind of running through various aspects of ocean atmosphere interactions in the context of climate dynamics. Right? Long interannual variability is climate, seasonal variability is climate, day-to-day variability is weather. So we are in the right ballpark. We will also get into climate change later on.